In this video I'll do this graphing problem example, and the first one, I might be able to do two in this video. First one says consider the graph G4, that's this one in the upper left corner. Which graphs are subgraphs of G4? And this won't take very long, I don't think. Let's go to graph B and look. Okay, so we have all the same nodes, first of all, same nodes. Looks good. And basically what I'm going to do is I'm going to look at each link here and make sure that it's in the other graph to the left. Okay, so this one is here, this one is here, this one from B to C, from F to I, from E to F. Looks just fine. This looks like a subgraph to me, and so I'll say yes. Okay, so I'll say that B is a subgraph of G4. I think we're using the operator that looks like subset to mean subgraph here. Okay, let's look at the next one. Oh, I see. I guess I should have started with A, but I started with B. Okay, so let's first of all look at the nodes. We're missing node B here, but it's a subset of the nodes. So we have nodes A, C, D, E, F, G, H, I. Okay, so we're missing one node. Let's check all the links now. We have this one, yes, yes, E to H, yes, H to D, yes, D and A are connected, A and E are connected. C has a loop. This one between A and C is a problem though. Even though A and C were formerly connected through B, this particular link is not in the original graph, and so this is not a subgraph. Okay. Next, graph C. Let's see here. No, I can tell right away by looking. I don't have an E to I link in the original graph G4, so I say this one's a no also. Okay, so that's a little bit of a lesson on subgraphs there. And maybe I'll move this on down. It says provide a description of the following graphs using symbolic notation B and C above. Okay, let's go ahead and do that. Graph B, let's call it a subscript B, is made out of vertices B and edges B. And the set of vertices B is the set A, B, C, D, E, F, G, H, I. Okay, the set of edges for graph B, and I'm going to go ahead and use these square brackets to distinguish this from a set. So the collection, let's call it the collection of edges for graph B, is including, and these are all unordered, A, D, so we put them in curly brackets, it's a set, so A, D, D, G. That's a lot of curly brackets, I know. DH, AE, EB, a lot of curly brackets and a lot of parentheses, BC, and now EF. Sort of making my way around this graph, EF and now FI. Okay, and I think that does it. Let's count, double check here. I have 1, 2, 3, 4, 5, 6, 7, 8 links and 9 nodes. 1, 2, 3, 4, 5, 6, 7, 8. Good. Let's look at graph C now. Graph C is down here. It's going to be slightly different. I hope you see that it's pretty straightforward to do this. Graph C is made up of vertices C and edges C. Vertices C include A, B, C, D, E, G, H, and I. parentheses in there. This is an E. Looks an awful lot like a C. There we go. And now my vertices, that was supposed to, yeah. Now my edges, the graph C, include AD. I'll just kind of go around DG, DH, let's see here, AD, AE. It's so easy. It seems quite straightforward. I hope you see that. EH, EI. It's almost tedious. I did the AEEI, so I need to do the AB now, and the BC. And finally, we have a loop, which is a single node. Okay, now what I'm going to do to check this is I'm going to count the number of edges and then compare it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Uh-oh, I'm missing somebody. Am I missing BE? I have BC, but I don't think I have BE. Yeah, I'm going to go ahead and add that one. You see how I had to check my work there? This is supposed to be BC. And I'll fix that up now. BC. And finally, I've forgotten BE. Very important to count when you're done. Okay, now we have it. So I hope that helps. This is an example of a graphing problem, a couple of graphing problems.